I welcome you to the next presentation on creational patterns. We have had the introduction to the patterns earlier on, and this is the discussion about the creational patterns. So, we know the definitions of patterns. We have got three parts: problems, context, and solution. So, a pattern offers a workable solution. We know that reuse is another particular point or issue in working around with the design pattern. Now we know three different stages. One is the macro level, then mini, and then micro. And the next thing is about the codifying the things with the coding pattern. So these particular issues we have already been taken care of. That is pattern's name, which has a handle, which has to solve the design problems, which has to generate certain solution. A pattern is like a template. Let's try to see to it. Likewise, sample template is being indicated here. Which type of design pattern the abstract factory pattern solves, and what kind of a solution it is being suggesting, and consequences. What happens is after applying the uh, patterns. So it's part of vocabulary. So GOF, as I have mentioned earlier on, it has been initiated in '93 by four people: Eric Gamma, Richard Ham, Ralph Johnson, and John Glisides. And it has been forwarded by Grady Bush, who is the principal founder of UML. It is UML modeling language. So creational patterns, we will concentrate on these three patterns henceforth. That is, creational patterns, they are used to construct the objects such that they can be decoupled from their implementing system. So this is the only regarding for the construction. Structure, as you all know, there has to be certain arrangement, that is the object structures between many disparate objects, and behavioral is to manage the algorithm's relationships and responsibilities between the objects. So 23 gangs of four patterns are being colored in different kind of ways. C stands for the creational, S stands for structural, and B stands for behavioral. So how you can remember these patterns, all the 23, there is a technique to remember. For creational patterns, you remember A, B, C, and then F, S. Just see to it. Add up abstract factory, builder, then factory method, then prototype, then singleton, right? So the focus of this presentation is to work out with these 5 creational patterns. There are multiple patterns which are been there mainly with the behavioral, right? So let us move ahead. Creational patterns, in other words, they deal with initializing and configuring the classes and objects, whereas the structural patterns, they deal with decoupling the interface and implementation of the classes, and the behavioral one, which deal with the dynamic interactions amongst the societies of classes and objects. See, object orientation has picked up many of its issues from human society. So creational pattern, abstract factory, if we take up a look at that it is a factory for building related objects, builder factory for building complex objects incrementally, factory method in a derived class creates association. That is what is the difference between the abstract factory and factory method. Factory method specifically highlights to the methods. Prototype, that is cloning new instances. That is, it's not duplicating, it's cloning. Yeah, having a copy and working around on that. Singleton, that is sole instance. We are not using this particular kind of an pattern as much as possible, that is singleton. Let us move ahead to the structural one. Adapter, right? Adapter is to take up some kind of an input and translate it into another kind of an stuff which is useful for client. So it acts as the, something more than an interface. Interface just forms a bridge, whereas adapter, it translates. Likewise, the adapters is in the 230 volts, okay, to the power supply that is being needed. Yeah, so adapters were being used. Bridge, to interconnect source and destination, that is to bind one or many implementation. Composite we have studied in the recursive aggregations, that is shown by a diamond box. Decorator, which works around on the external object characteristics. Flyweight, that is many fine-grained objects which should be shared efficiently. That is, flyweight is a kind of a thing which consumes lesser memory, yeah, and frequent ins and outs are been there. So behavioral one, they are having chain of responsibility. The names themselves are been sufficient, okay, to describe the purpose. Command, once a command is executed, you cannot interrupt in between. Mediator, similar to a broker, coordinates interaction between its associates. Memento, snapshot captures and restores object states privately. This is something comparable to prototype, okay, which works around with cloning, but here we are taking snapshots. Interpreter, I should not explain to you. Iterator, that is certain elements are being sequentially accessed. Strategy, that is abstraction for selecting one of the any algorithms. I repeat again, strategy for selecting one of the algorithms from the many. Observer, it is working about the dependence which update automatically when a subject changes. So this kind of a thing is being used in publish subscribe. If something is been modified at the server end, the clients will be also modified, right? The state is the one whose object, okay, behavior depends on its state. Alright, an object has got two things. One is the state, another one is the behavior. So just see to it, object oriented software development working as an volcano, isn't it? Yeah, whenever it would be erupting, isn't it? Many things will happen. So how to discover the pattern? Experience, do it by yourself and watch others doing it. That is another thing. If you are not doing it, watch others, how they catalog, how they work around, and then teach and learn. Probably this particular thing we are doing right now. And just see to it, there are certain 9 points which are actually the benefits, okay, of having the patterns. Any significant point, that is documentation and learning aid. It speaks about existing methodologies, right? It works around with the delegation and double dispatch. Enhancing communication and maintenance. So highly coordinating team are required, right? So pre-1970s, no formal methods were been there, only assembly languages were been there. 70 to 80, that decade worked around with the early O methods, and 1990s when O models were being matured, people have started thinking around the problem domain space mapping to solution domain space. So Maintainability, how to work out with the abstractions, isn't it, was the story, and how to work out with the uh, information hiding, that is, how I will not generalize the problem, how I can localize it so that the effect could be localized. So, how to, work out with the design pattern, scan the intent section. What is the applicability? Scan the intent section, how their patterns are being interrelated, and what is the purpose of that, what is the value of redesign in that. So, moving next, reasons for selecting design patterns are creating an object by specifying a class explicitly, that happens as with factory method, abstract factory, and prototype. All three are belonging to creational. Dependence on specific operations, right? Hard coded requests. Command will be but natural. Chain of responsibility will be also there. Dependence on hardware and software platform, APIs, and etc. etc. Abstract factory and bridge. Now remember here that abstract factory is creational, whereas bridge is the structural pattern connecting the source and destination. Dependence on object representations or implementations. So abstract factory, abstract classes are being mapped to concrete. Bridge is also there. Memento, where you take up the snapshot and you use it. Proxies, that is on behalf of. Whenever you are working around with proxy, remember the tagline on behalf of, right? And then algorithmic dependencies, strategy will be there. Can you find strategy? Yes. Builder, template method, and visitor. So the design pattern should support tight coupling here to work out with the monolithic systems and loosely coupled kind of a system. So we promote loosely coupled system so that they could become flexible enough. So example of this thing could be facade, mediator, observer. Okay, so one modification moves around to the rest level kind of a modification. So extending functionality by subclassing, then object composition in general and delegation. So we have got choices here: bridge, chain of responsibility, composite, decorator, observer, and strategy. Inability to alter the class conveniently. You may not have the control over here now. So adapters, they will work around on their own kind of structure. Decorator, that is external kind of an modification, and visitor. Next is the how to use the design pattern. Suppose that a design catalog has been presented to you, 23 patterns are being presented to you, they are categorized, and how to read them. Read the patterns once through for an overview. Read from the first line to the end line. Go back and study structure, participations, and the collaborative units. Look at the sample code skeleton. Don't forget to look at that, how the code has been arranged. Choose the names for pattern participants which are domain specific, which are application centric, which are representing the context of application. Define the classes, define the interfaces, define the relationships, and define the application specific names for operations. Right? Create user profile can have load user registration form. Now, load user registration form will not have any kind of a meaning in deliver the goods. Okay, so again that should not cross up with the user profile creation. Implement the operations to carry out the collaborations and so on and so on. So the aspects that can vary with the patterns, all 23 are been listed along with the page numbers. In the bracket, the page numbers are been written. Abstract factory 99, page number 99, right? So sequentially, you are having the till from 99 to 144 creational, right? And from 157 to 223, 233, sorry, the structural pattern. So, abstract factory is concerned about what? Families of product objects. Builder, how a composite object gets created, and so on. So, this is homework for you to read and understand, because right now we will be concentrating on the creational patterns. This is the list of behavioral pattern and their aspects which can vary. Right. So, the pattern space is being organized into two scopes. One is the class scope and object. Very limited are been there having the class scope. So let us have a look at this creational. They differ the object creation to another class, abstract factory singleton. Object creation is been deferred to another object. Decorator describes the ways to assemble the object. So randomly this has been picked up. So the class related scope is only applicable to factory, adapter, interpreter and template. So how you will be remembering it in short form? FAIT, factory, method, adapter, interpreter and template. Rest of the 19 are been there for object creation, right? Again, to remember FAIT, you will be remembering for class. So now you can have two level reuse. One is the white box reuse by subclassing, and black box reuse by object composition at a fresh. So the difficult thing has been there is white box reuse by subclassing, that is using the class inheritance. Now there are of course limitations which happens to be when you are using the principle of inheritance, right? So interface and the type is also important. So within the previous slide we have seen that FAIT has been there for class and rest of all are there for object creational. So finding the appropriate objects, determining the object granularity, that is up to what extent I should take down the hierarchy. Level 3, I have suggested that don't cross the level 3. And interface and its type, right? How many interfaces are being needed? Whether it consists of dynamic binding, whether it consists of polymorphism. The biggest question is that if we are having the inheritance, when we can use polymorphism, right? So this is what is also one of the things. Next is delegation. Delegation is a very special kind of a relationship. You allocate or assign something, okay, or delegate a larger scope of work to the other objects, right? Likewise, 100 responsibilities you want to carry out for a particular class or object in question, out of which you can have, let us say, 10 delegated to certain 10 objects. So the only role that is been remaining with the parent class or delegating class is to monitor whether those 10 responsibilities or services are being handled or not. But this kind of an decomposition, powerful, okay, as an inheritance, but hard to understand, and it will create runtime inefficiencies. Why it will create runtime inefficiencies? The thing is that always the information will go from the ladder bottom up. So you have to think about the composition here as well. So designing for change, what are the causes for redesign, doing the design again, creating an object by specifying the class explicitly, commits to a particular implementation instead of an interface. You are not changing just merely the interface, right? Now the patterns which have been affected due to that is abstract factory and prototype. All three are belonging to creational, right? Now dependence on specific operations, specific. So compile time and runtime modifications are avoided here. Chain of responsibility and command are the example. Hardware software platform, abstract factory and bridge, external OS API, they may vary. So if they vary, they will be limiting the platform dependencies, isn't it? What we want to achieve is platform independence, but here again we are falling in love of platforms, right? So patterns significant here are abstract factory, bridge, memento, and proxy, which are having dependence on the object representations. The second point is about the algorithmic dependencies, tight coupling, and subclassing, and having a convenience to alter the classes. So if you can alter the thing, modify the thing conveniently, then you can go forward for adapter, decorator, and visitor. But the challenge is that change might require modifying lots of existing classes. Okay, so one adapter doesn't work out for multiple, uh, software units, which has been thought in terms of classes. Tight coupling, tightly coupled classes are hard to reuse. Okay, in isolation. So as far as possible, we work around with the loose coupling. Multiple patterns are there working around with tight coupling from creational pattern, abstract factory is the only one. Okay. Then many of them are being there, okay, with the structural and behavior, mix of that. Bridge, then Packard, they are the two, and the rest of the uh, patterns are belonging to behavioral patterns. So let's move now to the relationship amongst the patterns. They are colored differently. Just try to see to it. Singleton will remain in isolation. Okay, singleton, right? Singleton we are not supposed to use as far as the things are being concerned. Adapter, proxy, and bridge. They are the separate kind of an implementation, so kept aside. So the yellow colored kind of and stuff is been indicating the behavioral uh, design patterns. The dark blue color indicates the creational, whereas the light colored they are been indicating the structure. Likewise, the abstract factory, factory method, builder, prototype, and singleton. They are the examples of creational. And adapter, decorator, composite, bridge, flyweight, Paka, they are all been belonging to structural, and the rest of all is been belonging to the behavior. So the chain is that if you want to have an composite kind of a design pattern, you can enumerate the children by using an iterator. If you want to save the state in iteration, isn't it? You can use memento, right? Because you can take the snapshot there. So decorator that varies the skin, that is outer kind of an presentation. Then you can use the decorator that works well with strategy. Yeah, this is how you have to interpret this diagram. Looks big, but it is simple enough to understand. Creational patterns abstract the instantiation process and works around with class inheritance and object inheritance. Just see to it that what it is been there. We have studied class creational patterns and object creational patterns, what they are. Now these two lines are very, very important for us. The class creational patterns use inheritance to vary what they are using. Inheritance to vary the class of object being created. Whereas object creational, they delegate. Again, runtime inefficiencies are been there for object creational, okay, creation of an object to another object. So only limited kind of an patterns are been there with the class creational. Just try to see for the example. Sometimes the creational patterns are being known as the competitors. A builder can be implemented using one of the other patterns such as factory, uh, abstract factory for creating components. Prototype can be implemented using singleton, but singleton is an indicator of monotonous behavior, right? So let us have a look at now directly to the uh, dropping down these two slides. Hard coding behaviors. Okay, just see to it. Hard coding behavior. Somewhere this line has been there. Okay, hard coding behavior to the towards the smaller set of basic behaviors. That will be inflexible. Hard coding it. Creational patterns, they make design more flexible by what? By making the availability, like here in this slide has been mentioned, that to vary the behavior, the class creational patterns use inheritance, whereas object creation they use delegation. Inheritance versus delegation, parent child versus container containee, right? But it is not whole and part. So now creator, it declares the object interface and returns the object. Now this is the foundation theory. Creator declares the object interface, returns the object, and the next thing is concrete creator that implements the object interface. Now with the implementation of objects interface, what you are going to achieve, you can see the copy of creators, isn't it? Through the interface you can access that. So therefore out of these patterns from gang of 23, the few things which we are not aware of: object pool pattern is avoid expensive acquisition and release of resources, and lazy initialization, that is tactic of delaying the creation of the object. So therefore whenever the process has been needed first time, by that time you can defer its creation. That is what is the lazy initialization pattern. Now the next story is directly beginning with the abstract factory, that is object creational. Intent is to provide the interface for creating the families. Okay, so families of what? Dependent objects. So it is known as a kit. From a kit you can create multiple kind of classes which can be maintained separately. So just have a look at the diagram. Widget factory will have motif widget factory, PM widget factory. So now the client will refer to the concrete classes. Abstract classes are been indicated, right? Widget factory, motif factory, NPM widget factory. They have been abstract classes. So the client takes up the concrete stuff as windows, that is PM window and motif window, and from that it controls the PM scroll bar and motif scroll bar. So therefore this is a better diagram to understand. Abstract factory, there are two operations: create product A, create product B. In concrete factory we are taking the all of the operation set of abstract factory, that is concrete factory 1 and 2, to generate the instances. Now with the client can refer to abstract product A, B, you may say C, why not? So it will suggest about product A1, product A2, product A1, product A2, then product B related, product B1, product B2. So you can easily understand here that from the concrete factory you are referencing to the discrete kind of elements, and this is the way that the abstract factory, that is object creational, this is working around on delegation principle. Again to remind you, object creational means delegation and class creational means inheritance, right? So there is the example, isn't it? It has been explained in words for simplicity. What are the benefits? The abstract factory provides a focus during the development for changing and controlling the types of objects and family of objects are created by object factory will work together because they are being bound by the principle of delegation. Disadvantages: easy kind of an creation of the products is not possible. So related methods or related patterns are factory method, prototype where you are working around with cloning. We should understand it with the examples, right? And the consequences: it isolates the concrete classes but natural. It makes exchanging product families easily because you are working around with the concrete classes. It promotes consistency amongst the product. You can form the product groups related to product range A, right? Let us say soap. There are varieties of soaps, right? And washing powder, right? Varieties of different brands are been there. Okay, product A, product B, product C, like that. You can create it for the two things. Okay, this is merely for your understanding purpose, right? Likewise, there are variety of toothpaste, toothbrush. Okay, indicating separate kind of a product, right? And then you can have the categorization and classification. Again, we remember that this is belonging to delegation. Builder. This is again object creational, means working around on the delegation principle. Alright. What is the intent? Everywhere we were being advised to read this intent very carefully. Separate the construction of an complex objects from its representation so that the same construction process can create a different representation. Now just compare this in common sense. There is a builder who is having a layout, and that layout is being used at multiple places to create multiple buildings. And one type of building can be only painted exteriorly in a different kind of a color combination or according to the floors permitted, so that the carpet area could be actually allotted to it. So you can create multiple kind of buildings with the kind of same kind of representation of the complex object. Yeah. So motivation here, that is related to the example. Now let us go to example directly. Yeah. Builder is text builder. Concrete builders are ASCII builder, text builder, and text object builder. And controller classes are RTF reader, and the results are ASCII text or rich text. Right? Try to understand. Builder is text builder. Concrete builder is ASCII text or text object, and the resultant is ASCII text or the rich text. Now just see to it that how it happens is. Who is who first of all? Just see to it. Who is the RTF reader? Go back and see. RTF reader is the controller. RTF reader is the controller. Now builders, text converter was the builder. ASCII text and text widget converter, they are the concrete objects. Just see to it, go to previous slide. Concrete builder, ASCII builder, text and text object. So the outcome now, the outcome is ASCII text and the other two text types. So just see to it, some of the things from the abstract class, okay, that is the text converter, are been applicable to almost three, that is convert character, yeah, get ASCII text. Now here three important things, okay, are been applicable, similar kind of a thing, that is convert a font change, convert a paragraph is been there, and specific kind of an operation has been added, get ASCII text, get text and get text widget. These are the specific things which are being applied. So that happens is in the object creation, that is working around with the delegation. Hope so that you have understood the delegation. Builders, buildings will be there with some of the features retained, some of the features are being added. Therefore, a builder has got concrete builder that will create a product, and the director is the controller one. Okay, you can control the builder, right? So this is the message sequence chart. A client request to a concrete builder and new director is there. Build part A, build part B, build part C. This has been done from director, that is controller, to the builder, concrete builder, and get result for the client. So there are merits, and these merits are, you can differ the characteristics of the object. Yeah, it addresses the modularity issue. Increased modularity will be there. Multi-level decompositions are possible. Multiple instances can be created and can be separately managed. Next is when the builder shouldn't be used. This is very critical. If the interface is not stable, then there is no use of builder. Every interface change requires a change to controller, because it is the controller who will enable the communication between the client and the concrete products that are being built up. So a new method would require changing the base class and all of the concrete classes. So one change at one place will reflect the changes at another level. So that is what is the observation is. Toy examples are not good representation of the power of builder pattern. Right. So builder pattern fits when objects needs to be created and the interface to those objects is well defined. So export functionality has to be there. Export to how many kind of parts, visibilities are being assigned, and do we have distinct kind of interfaces. So consequences, it lets you know vary a product's internal representation. It isolates the code for construction and representation. Each concrete builder contains all the code to create and assemble particular kind of product, and it gives you finer control over construction process. Right, just see to the director. Yeah, director's control. Next is the factory method. We have seen up till now two design patterns. One was abstract factory, another one was the builder. Now this is class creational. This works around with the principle of inheritance. Right. This works around with the principle of inheritance, to recollect you. The intent is to define an interface for creating an object, but let the subclass decide which class to instantiate. I read it carefully once again. Define an interface for creating an object. You have an interface for creating an object, but subclasses will decide which class to instantiate. So director level control like it was been there with the builder is not applicable here. So factory method lets the class differ instantiation to the subclasses. That is what is the intent. Yeah. So we have to use the factory method when a class can't anticipate the class of objects it must create. This is a figurative kind of an assessment, which is the thing that is to be triggered. How many subclasses would be instantiated? Okay, so helper subclasses will be arising, isn't it, here in this case, because you work on the inheritance principle. So just see to it over here, document and the application. So my document holds up a document which has got open, close, save, revert and whatsoever and whatnot, and an application can have demands likewise, new document, open document, date document, and my application, that is the currently existing thing, that will just say create document or whatsoever new my document for documentation purpose. For product, the product is being created by factory method, that is creator. The concrete creator will create new concrete product. Now it is the job of the interface to create the concrete product and to work out with the product in question. So there will be product 1, 2, 3, 4, 5, 6, 7 and like that can be constructed with the help of factory method. Factory method is just like the same story that a shirt of size 42 has to be created. So all the pool of workers are been stitching around the size 42. Exclusively for 44, how many to instantiate? That you have to suggest. 38, you have to suggest. 46, extra large, right? 48, 50s and 52s, okay? So right kind of imbalance has to be there, right? This is merely for the sake of your understanding, right? So participants are the product that defines the interface of the objects, concrete product that implements the product interface, that is the demand is being raised by concrete product, creator which creates or returns the object of the type that is being demanded by the product, and concrete creator is overriding the factory method, and method level controls are being applied over here. So advantage, best to use when there is a default way of creating objects. Genericity, no need to bind the specific classes because you are going through the interface efforts. Disadvantages, it may result in large set of subclasses of abstract classes. So you can have multiple things which will be indicating multiple diversionary kind of an interfaces and multiple kind of an instances will be there. And what about the maintenance then? That would be the question mark. So graphic tool, in that you have got circle and square. The shape is circle and square. If you want to derive it, okay, circle and these things has to return a new circle or a new square depending on the request, right? So you can move, draw, color, isn't it? What kind of an operation you want to include, you can include. So let us move ahead to the two important points. Provides hooks for subclasses because it works on an interfacing. It provides hooks for subclasses. Connects parallel class hierarchies. That is but natural. And now we move ahead to prototype. Now what is the intent of prototype? Prototype and cloning. Just see to it. Specifying the kinds of objects. It is again object creational, means the principle of delegation is been followed. The delegation happens at the leaf node, isn't it? At the instance level, motivation is to copy the objects to create new objects, right? So the principle of cloning is used. Cloning is different from snapshot. Cloning is different from a stub that is taken as a copy, right? So tool, yeah, you may use rotate tool, graphic tool. So out of that graphic tool is being used. Okay, this staff, okay, is a cloned kind of an stuff. So at the concrete level, you will be having the cloning. These are not the original ones, right? They are returning the copy of the cell. Alright, so that is what is the important thing about cloning. Keep an copy with you. Your copy is your own copy, right? Likewise, there are hundreds of textbooks of different colors. You are selecting certain three colored books, red, green and blue. And you are keeping it with subjects, physics, chemistry and maths. Right. Now it is your preference that red colored books, you should use it for maths, or you should go ahead with the physics. Next is the client demands the prototype. It will create the clone from the abstract. It will create the clone. It's a duplicated kind of an effort. The original copy is not been damaged, but the clone is giving a permission to have the copy of the same for your own reference, right? So the clones are not the actual ones. Humans are have had researchers about cloning, mixing up the characteristics and returning the copy for the self, right? So how the call is being generated? P is equal to prototype and then have a clone for me. So prototype will be having a clone for itself. So this is a definition part, right? Create the factory class, create the clone, indicate the references and make use possible, that is return a copy for yourself. So here the prototype pattern structure, client demands the operation, clones are been made available, that is the product type, factory type and product type, right? So client will demand some things from its own kind of a library for own particular purpose, right? And then this is just like similar to a web application. A web application could consist of, let us say, 100 features and 100 functions. You may sort the features which are being useful to you and you will be using consistently, right? So music editor, this is another example of product and factory, right? For the sake of understanding, you use prototype for cloning. So collaboration diagram is also been drawn. Okay, I hope so. So purpose I have explained to you. Okay, the new object can have a deep or shallow copy of the prototype, deep or shallow. But the thing is that the results are being retained. That is what is the thing that you have to remember about prototype. Yeah, and applicability, dynamic object specification, and no class hierarchies of factory classes, automatic extension of class inheritance tree. This is the biggest benefit that you can derive, that is from the prototype. And prototype versus abstract factory. Abstract factory is considered to be the pure one, whereas prototype is consisting of only factory class if needed. So there is no hierarchy that is being presented. Only at runtime instances the concentration is being made with the prototype, right? So prototype versus builder, we are knowing that one particular representation and multiple representations is the builder. Prototype is it has only one factory to create product objects. So the freedom has been gone in case of a prototype, right? So it is lesser flexible. Okay. Benefits are it hides the concrete product classes from the client code. So it reduces the number of product classes needed because only one label, that is factory classes, is being worked out. I mean the uh, abstract classes are not being touched, okay, in this kind of thing. So consequences are there, okay, adding and removing the products at runtime, varying values for objects, reduced subclassing. You are not following nesting of classes or increased kind of an uh, detailing. So only one level kind of an cloning is needed. Singleton, the thing that we are not recommending, okay. Object creational again, so works around with the delegation, ensures a class only having one instance, provides global point of access to it, global point of access. So it promotes okay, high level coupling or content coupling. So that's why global variables and global themes doesn't make multiple kind of an sensible approaches. So it has got sole instance which can be referred singleton. Yeah, I am the alone. Use me in the way you want to. There are no branches or whatsoever that I can provide for you, right? So singleton instances is a class operation which is static in Java. It has got unique interface because you are trying to access the uh, global properties, controlled access to sole instances, reduced namespace, permits refinement of operations as well as representations, and more flexible than class operations because uh, you are making available just a single unit, right? That can be referred. So lazy initialization is one of the thing that happens is okay, that is which is having shared state. But shared state is bringing up another danger, that is to refer to the current state and modifying the next one. So multi-ton pattern in software engineering it is similar to singleton, multi-ton, which allows you only to have one instance and then use up that instance. So you may have a more flexible approach registry of singletons and you can refer to that registry. Object pool I discussed earlier on, okay, and what is the problem is handling the empty pools, and there could be a performance boost in situation where initialization cost of the classes is high. So probably that marks up the end of the session.